Hello, this is Professor Mitchell, and this is part 2 of section 4.6, Graphs of Other Trigonometric Functions. In this video, we're going to be looking at the graphs of secant and cosecant functions. In part 1, we looked at the graphs of tangent and cotangent functions. So the objectives for this video are to understand the graphs of y equals cosecant x and y equals secant x, and to graph variations of those functions. So this is going to work a little bit differently from how we graphed sines, cosines, tangents, and cotangents. We're not going to follow the 5-step procedure that you saw in 4.5 and earlier 4.6. This is actually going to be a little simpler. Graphs of cosecant and secant functions are always based on their reciprocal functions. Cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. So when you're asked to graph a cosecant function, we're actually going to graph the corresponding sine function, and then we're going to do the same thing for secant. We'll graph the corresponding cosine function. So again, we obtain the graph of y equals cosecant x by taking reciprocals of the y values in the graph of y equals sine x. And we're going to have vertical asymptotes in the graph of y equals cosecant x whenever the graph of y equals sine x has an x-intercept. And that's because x-intercept occur at values of the function that equal 0, and the reciprocal of 0 is undefined. And then the same thing for secant x. We're going to take reciprocals of the y values in the graph of y equals cosine x, and we're going to have a vertical asymptote whenever the graph of y equals cosine x has an x-intercept. This is the graph of y equals cosecant x. So let's look at some of its characteristics. Its period is 2 pi, same as y equals sine x. Its domain is all real numbers except for integer multiples of pi. And the reason that those values are excluded from the domain is that those are the same values that make the sine equal 0. So when you try to divide by 0, you get an undefined value. The range of the cosecant function is all real numbers y such that y is less than or equal to -1 or greater than or equal to 1. And you can see that from the graph. Notice that the top part of the graph doesn't go any lower than y equals 1, and the bottom part of the graph doesn't go any higher than y equals -1. Before we go any further, I want to share with you how my first trigonometry teacher helped us to remember the graph of y equals cosecant x. It's very, very silly, and that's probably the reason I've never forgotten it. So again, you start by looking at the graph of y equals sine x, which you see right here as a dashed line. So when you have that graph in front of you, the next thing you do is place all the vertical asymptotes, and they occur whenever the sine is equal to 0. So that would be right here, 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 and here at all integer multiples of pi. And then what my first trigonometry teacher said, to get the graph of y equals cosecant x, you start at this first vertical asymptote, the graph of the cosecant function comes down, it gives the sine graph a little kiss, and then it runs away going tee. And I have never forgotten that. And that was a very long time ago. Same thing happens down here. As you cross this vertical asymptote, the graph of the cosecant function comes up. It gives the sine graph a little kiss and runs away going tee. And it keeps doing that same thing over and over again, here and here, and it would just repeat that over and over. So notice that one period of the cosecant function includes one of these upwards opening curves and one of the downward opening curves. We have vertical asymptotes at all integer multiples of pi, so those are all the values of x where the function is undefined. And recall from a few sections ago that cosecant is an odd function. which means its graph is going to have origin symmetry. Hopefully you can see that origin symmetry in the graph. And now let's look at the secant. So the period is also 2 pi, the same as cosine. It has a different domain than the cosecant, all real numbers except odd multiples of pi over 2. Those are the same values that make the cosine equal 0. It has the same range as the cosecant function, all real numbers that are greater than or equal to 1 or less than or equal to -1. It has vertical asymptotes at all of those values that make the function undefined. And it is an even function. Remember that secant and cosine are the only two trigonometric functions that are even. The four others, sine, tangent, cotangent, and cosecant, are all odd. An even function has y-axis symmetry. Hopefully you can see that in the graph. Let's look at our first example. So again, the way that we graph a cosecant or a secant function is start by graphing the corresponding reciprocal function. So in this example, they've started with the graph of y equals sine of x plus pi over 4 already drawn. So refer back to section 4.5 for the steps in how to graph a sine or cosine function. The next example will be broken down into a little more detail. So we'll go over those steps a little more. But in this first example, we're starting with the sine graph already drawn. And we're going to use that graph to get y equals the cosecant of x plus pi over 4. First thing we're going to do is notice that the x-intercepts of the sine graph correspond to the vertical asymptotes of the cosecant graph. So at every x-intercept, we're going to place a vertical asymptote. Here, here, and here. And now, remember how I explained how my first trigonometry teacher explained this? So we're going to start at this first vertical asymptote, comes down from up here, gives the sine graph a little kiss, and then runs away going hee hee. And then it does the same thing down here, comes up from this way, gives a little kiss, runs away going hee hee. And it just keeps repeating that over and over. And we end up with a graph that looks like this. So in red, you have the graph of your sine function, and in blue, you have the graph of your cosecant function. The next example, we're going to graph y equals 2 secant of 2x over the interval from -3 pi over 4 to 3 pi over 4. And this time we'll break down the steps a little bit more, how to get the cosine graph. So we're going to begin by graphing the reciprocal function y equals 2 cosine 2x. I've always felt, and this is maybe just me being picky, that it's not technically correct to call this a reciprocal function because the product of 2 cosine 2x and 2 secant 2x is not 1. It's 4 because the cosine and the secant cancel each other out, but 2 times 2 is 4. So just remember that in this context, when they say a reciprocal function, you're not taking the reciprocal of this coefficient out in front. You're only taking the reciprocal of the trig function. So this equation is of the form y equals a cosine bx, where a is 2 and b is 2. So remember the things that we looked for in the last section when we were graphing a cosine function. The amplitude is the absolute value of a, which is 2. The period is 2 pi divided by b. In this example, that comes out to pi. So we're going to use quarter periods to find x values for the 5 key points. Remember that the first x value occurs when the expression inside the cosine is equal to 0. So we're going to set 2x equal to 0, and that's going to give us x equals 0. And then we're going to go up in increments of period divided by 4. Remember that the period was pi. So we're going to go up in increments of pi over 4. And that's going to give us 0, pi over 4, pi over 2, 3 pi over 4, and pi. So now we're going to plug those 5 values into the cosine function. Remember, we have to graph the cosine first to get the graph of the secant. And so you plug those 5 values in and you find that the points on the graph of the cosine function are 0, 2, pi over 4, 0, pi over 2, negative 2, 3 pi over 4, 0, and pi, 2. So we're going to graph those 5, and you end up with one period of the function looks like this. So now how we use that to get the graph of our secant function is just like in the last example. We're going to place our vertical asymptotes at all of the x-intercepts. I can see 2 x-intercepts on this portion of the graph. There's one there and one there. And then, just like I was describing to you earlier, you use those portions of the graph, in this case of the cosine, to get the graph of the secant. So you end up with something that looks like this. Notice that it's also been extended to the interval that they wanted. They wanted the graph over the interval from negative 3 pi over 4 to 3 pi over 4. So we'll end with a summary of the 6 curves of trigonometry. So this is a good thing to remember as you move into pre-calculus and calculus. Just what do your basic trig function graphs look like? Here's y equals sine x, y equals cosine x, y equals tangent of x, which we went over in part 1 of section 4.6. The cotangent of x, and then we just went over y equals the cosecant of x and y equals the secant of x. So between sections 4.5 and 4.6, you now know how to graph any trigonometric function.